Hello. Today I'm going to walk you through a bit more of the algorithm that underlies Evil Hangman, and that you guys will be implementing in this next homework assignment. If we remember, Evil Hangman works and is evil because rather than keeping track of one word for the client to guess, keeps track of a set of possible words that could be the client's answer, and delays choosing the word until it absolutely has to. In order to do this, Evil Hangman keeps track of a set of words that could possibly be the client's answer, and also keeps track of a pattern. And this is basically showing the correct letters that a client has guessed, as well as and the locations in the current pattern. We'll note that the pattern starts off empty because the client hasn't guessed any letters. So what happens when the client guesses a letter? Say the client guesses E. Well, Evil Hangman will go through and build up a map that associates patterns to words, that contain the letter, to words that have that pattern given the current guess. This may be a little confusing, so we'll walk through an example that'll detail this a little bit more. If we look at ally, does ally contain any E's? No, it doesn't. So what we want the pattern to be for ally is just the empty pattern again, right? There are no E's. And you'll see our first entry in the map is a key that's the empty pattern with a value, and the only word in the map in this grouping of words is ally right now. If we look at beta though, we see that beta does have an E. So our pattern is going to be not the empty pattern anymore, but rather it's going to be dash E dash dash. We can see that we appropriately update the map with this entry. Cool, well, again, cool doesn't have any E's, so what pattern is it going to fall under? Exactly, the empty pattern again. So we'll see that cool gets updated into this version, or into this entry in the map. And then finally, if we keep going, we see deal has one E, and it's in the same exact place as beta. But when we get to something with slightly different pattern that also has E's, we see we update a new entry in the map. So else has a pattern of E dash dash E. So if we update our map appropriately, we see we have a new entry with a new key that's different than this pattern over here, even though both contained an E. And flew, well, that's going to be a new pattern as well. And we can walk through. Good, again, contains none. And then hope contains one E at the end. And ibex, well, that contains the same pattern as flew. So now, Evil Hangman has to choose the next set of current possible words, right? We have to take into account the user's guess, which we have by building up this map. So what set of words should the Evil Hangman be considering next? Exactly. The Evil Hangman is evil, so it'll be considering the largest group of words possible, in which case this is the empty pattern. So you'll note as we go on, our pattern is updated to still be the empty pattern because that's the pattern of this grouping of words. But our current words is now only these group of words. And now we can repeat the process with another letter. So if the client guesses O, we go through and we build up the pattern map for O, considering this pattern as well, and this new grouping of words. So we can see that this is done. Ally has no O's, so it has the empty pattern again. But cool and good each have two O's in the middle, so they have this pattern. Again, Evil Hangman will choose the set of largest words to continue on with. And as we see, the pattern over here gets updated to reflect the pattern of the current grouping of words. In this case, it's dash OO dash because that's the pattern that cool and good both have. Let's look at one last example. If we guess D, we'll notice that we're going to build up two different patterns in our map, right? Cool does not have a D, so it remains dash OO dash, but good does have a D, and so it changes to dash OOD. It's important to note that these patterns maintain previous guesses, such as O, in their pattern. And now, which one should Evil Hangman choose? Well, we're in a tie here, and the spec will point out that you should break ties by choosing the earliest occurrence in the map. In this case, the pattern gets reflected to be dash OO dash, and the current set of words would be cool. If we go over to the course homework page, you'll note we do have some of the normal resources. It's important, as with every assignment, to read the spec carefully, as it will outline requirements for your implementation, as well as some useful hints that may help you get started. These first methods in the method table are going to be fairly simple to implement, but record is going to be the method that is a little bit more difficult, and I recommend you implement later in the assignment. This is the method that does the bulk of the algorithm I just described earlier in this video. You'll also note that we give you Hangman main, which is a client program you can use to test your Hangman Manager class, along with some sample outputs that you should be using the output comparison tool to check your output versus these given outputs. You'll note that we give you two possible dictionaries to use. One is a fairly large and robust dictionary. The other is a shorter dictionary used for testing. As you debug your program, I recommend you use the shorter dictionary, and you can change which dictionary Hangman main uses by updating the dictionary file class constant in Hangman main. You'll note we also provide you this helpful diagram, which is the same diagram that I showed on the slides, and will be really useful if you need to step through step by step to really understand how the algorithm is working. I believe that is all I have for you today. Oh, lastly, we have some of the normal resources we provide. As usual, when thinking about style for this assignment, you should be referring to the general style deductions and the style guide, as well as the commenting guide to help you form your comments. And then we also provide frequently asked questions and the message board for you to answer any questions or clarifications you have as you work through the assignment. Now, that's actually all I have for you. Good luck implementing Hangman Manager, and I hope you have a great rest of your day.